Hey guys, welcome back to another video. So here I'll be showing you guys how to use the chi-square test when it comes to a two variable problem. In this case, we use something known as the independence test. And this is to show whether or not that one variable is independent of the other. In my case, I chose a region by price. In other words, I'm checking whether or not the selling price given by these units, anything, let's say euros or pounds, is actually independent or not of the region it's in. It makes sense because prices in one area will be more expensive than others. So the first thing you want to do is set a null hypothesis. My null hypothesis is that the price is actually independent of the region. This means our alternative hypothesis is that price is not independent of region. So let's try this using the goodness of fit test for independence. Now the first thing you want to know is firstly, what do we do? So what we need actually is we need to follow this formula, okay? We need to calculate this double sum formula, which is the expected value minus, the actual value minus the expected value, all squared over the expected, okay? This will give us something known as a Q ops value. And by the way, these sigmas represent an I and J row, yeah? So here's our I's and here's our J. I represents a horizontal, J are vertical. So we need to actually sum up across and downwards. Okay, and this will go up to our total number. So across our I's, we've got 3 and J is 2. And we're going to get to this here. But before we get here, now we need to actually work out what is our expected, which is the pink box here. We need to plug in these values, and then voila, we can actually figure out what to do with this. So let's do this thing. So first things first, let's have a go, yeah? So on this row, let's call this the total. So we need to find the total of everything, okay? And what I want you guys to do is to sum up everything downwards. So I'm going to do it quickly because it's easy on Excel. So yeah, you can do this on paper, by the way, but Excel is just faster to get done. If it's for an exam, then see this, just check out how I do it. So find the total vertically and horizontally. So find it across too, which is, it's not 0, I don't know why I say 0. Oh, it's 80, yeah, so sometimes Excel is a bit slow, guys. And then do it downwards as well. And then most importantly, you need to find the grand total. So you should have the same value as if you add these three across, or these two. I'm going to add these two and get 200. Now, to calculate the expected, it's simply going to be the product of the I and J corners. So it'd be, for example, for this corner, to get the player a value similar to 29, it's going to be 70 times 80 over 200. So I could say this value times 80 all over 200. And that's it, 28. And you just have to repeat that all the way across. You know, just because it's Excel, there is quick ways to do it. You know, I'm just going to lock F9 for a second. So let me just do it quickly, guys. Hold on. So F9, F7. So lock this way and lock C9 and then lock F9. Okay. So anyway, do your multiplications. Do the same thing. So for example, 32 is going to be 80 times 80 over 200. This value is going to be 50 times 80 over 200 times 80 over 200, which will give you this corner. Do the same thing all the way across. You know, I'll just do it down as well. Let me see if I get the same correct figures. Yep. So don't worry, this will calibrate on its own. Yep. So it's fine. And then you realize that if you sum all this up, you should get the same value of 70 downwards, all the way across here. By the way, it's just slow. My Excel is really slow, isn't it? And then do the same thing. You should get, of course, 200 here. Okay, so this is the first step done. Now we got all our values, so now we can plug all this into a formula, and yeah, literally subtract every single corner. So what I need to do now is I'm going to scroll down slightly, guys, and make another copy of this. And I'm going to do this formula here. So let me just do something fast. So we need 3 tables here. Let's just break it down nice and easy. Yeah? So I'll delete this, this, and this. Okay, so just clear this out, and we're going to call this one Q obs, so we can actually find out the total value Q obs. Okay, so applying the formula is going to be the actual, so plug in carefully, so it'll be this value minus the expected value, all squared, and then simply divided by the expected again. Trust me guys, Excel is just life. It literally does it so quickly. Squared divided by its respective expected value, which is here. Why is it 120? There you go. So looking like something like this. When you press enter, yeah, typo. Let's have a look. Squared divided by this. Yep, that's correct. So you have to get basically a small figure. That the reason why it's small, because you can see 29, 28 is pretty much the same. So the margin error is going to be tiny. So let's just tie this value up. So it'll look very small. I'm just going to round up to like a couple of simple figures. Do the same for each cell, okay? Apply the formula carefully, and you should get some decent representative values. Let me just make the numbers clearer. And that's it. You've literally done it. Now all you really have to do is just simply sum all these up to get our QOBs. So our QOBs here, let me just bring these down here. And also my degrees of freedom. So we can say firstly that the degrees of freedom formula is always going to be the number of cells across. So we've got 3 across and subtracted by 1, so it'd be 3 take away 1 times the number of, okay, that was horizontal, times the number vertical. So there's 2 variables and we subtract that by 1. You always subtract 1 by each column and row. That gives us exactly 2 degrees of freedom. And now the QOBs is literally going to be, based as the formula says, the sum of all of it, which is 7.48. And now as for the chi-squared, we just have to refer back to the table value at the 5% level. Okay, so now all we need to do is pretty much find the table value at the 5% level and at 2 degrees of freedom. So let's flick over to the chi-squared table. So okay, so here we are. So as you can see here, this is your distribution. The yellow region, if you remember, is the area of rejection. So if your observed value is bigger than this table value, which is over here, then you will definitely reject. So let's have a look. So we've got 2 degrees of freedom, and we're going to look at the 5% level. So we're going to use the value 5.991. Okay, put over here. I'm just going to paste it in. Okay, so yeah. So if you can see carefully, so I'm just going to make the values a bit bigger here. There you go. So you can clearly see that the observed value is bigger than this one, and that's it. Now we just have to reject null. So my conclusion, as I stated, is there is enough evidence to reject the null clearly because the Q observed is bigger than your critical value, and so price is not independent region. If you recall carefully, the null hypothesis was that price is independent, assuming the null is true. The alternative is going to say is not, and that's it. Simple as that. Suppose the observed was lower. Let's just say, for comparison sake, we go like 4. Then you can see that there is not enough evidence to reject the null, and the price is independent. And that's it, guys. I hope this video helped, and let me know if you've got any other questions.